Hi, I'm Ryan Holger with TEC Tube, and today we're going to be discussing the sequence of operation of a packaged rooftop unit. First we'll do the cooling side, and then we'll touch on the heating side. Let's go ahead and get started. Major components on our cooling system. We'll start with the compressor. That's the heart and soul of any cooling system. His job is to move refrigerant from point A to point B. What's point A and point B? All right, so over here, this would be on our roof, obviously. Air would be coming up from the building, going through this evaporator coil, which is going to have cold refrigerant running through it. So it's going to absorb the heat from the air of my building. And there's a fan on the other side that's pulling that air through and sending it back into the building nice and cool. That heat from this coil gets pumped by this compressor over to the other coil. This is our condenser coil. And he has his own fan on him. He's going to be pulling air through him to take that heat and then reject it away. So one coil's job is to absorb the heat from the building and hence cool the air. The other guy's job is to take the heat from the building and reject it to the outside air. And this compressor in between is just going to flow between the two of them. Let's go ahead and fire it up. So when I fire this guy up, what's going to happen is I'm going to go down to the thermostat. I'm going to toggle the temperature to say that I want it to be colder than it is. It's right now it's 73 in the room. I'm going to ask to make it 70, for example. And because it's warmer than the set point, the cooling is going to turn on. What that means in the thermostat is two little switches close. One is for cooling, which is Y and R. The other one is for the fan, which is G and R. So the fan and the cooling turn on together. The fan means the indoor fan that we were talking about before, the evaporator fan. And the cooling means the compressor and the condenser fan will turn on. So all three of those guys will turn on at the same time. The compressor's actually on, condenser fan's on. It's kind of hard to visualize airflow, so I'm gonna use this piece of paper. As you can see, it sucks the paper to the coil because it's sucking the air in. And then it's going through there, picking up that heat and ejecting it out. So as you can see, this guy's blowing the air upward. Now sometimes I'll tell the thermostat to call for cooling and the compressor will not come on at all. That's because we might be in what's called an economizer mode. So there are some times that you don't want to run the compressor. If it's cool outdoors, but warm in your building, why not just suck the free cold air in? So this unit is not equipped with an economizer. But if it was, we would have another section on this unit that would allow me to pull fresh air in directly into that filter and into that evaporator coil from outside, nice cool air. We have another video explaining how that economizer works, so we'll let you guys take a look at that. From a sequence of operation perspective, the thermostat would still call for cooling by closing that relay for Y and G, but now that Y signal will be intercepted, go to the economizer. He has a sensor to check the outdoor air temperature, and if it's good, use the economizer. If it's not good, we use the compressor. Now for the heating sequence. Let's look at some of the components on a gas-fired rooftop unit. So for starters, we have a gas valve, obviously, because we have to have something that controls the flow. It'll either be an on-off valve, meaning one stage, or it might be a two-stage gas valve, which means I can turn on part way and then turn on all the way. And then on really complex systems, you might have a modulating one. But for rooftops, it's typically one or two stages. So I have a gas valve on here that's going to allow the flow of gas coming into this connection to be sent into the burner over here. I have an inducer motor. His job is to pull air through the combustion side of the system. So I have airflow going through the heat exchanger because of the fan. That's the air from your building. That's not the air we're talking about now. Right now we're talking about combustion air. That's going to get sucked into the cabinet, go into the burner, go through the heat exchanger, and then come out this inducer motor right here. So I have a small fan in here we call the inducer fan in order to move that air through the combustion side of the equation. So there's really three fans in a unit. Condenser fan outside for cooling, inducer fan inside the unit for heating, and then my main blower for all my airflow inside the building. So gas valve, inducer motor, back there, which is a little hard to see, we'll show you a closer view of it in a little bit, is our actual burners. So we have multiple burners in there. They're going to be shooting, if you will, shooting flames into the heat exchanger. And then we have some safety protections on here. Up inside here, we have a pressure switch, which is what these hoses are connected to. Or this hose right here, the gray one is connected to. We have a pressure switch. So if I'm not able to move air through this fan, because something's blocking it, a bird built a nest in here or whatever, that pressure switch is gonna realize it and shut the whole thing down. We don't need to start making a fire inside the heat exchanger with no way to get rid of the products of combustion. So that's the part of that pressure switch's job. We also have in here a limit switch over here on the heat exchanger. And when I open up this cabinet here, you'll see the heat exchanger. That guy's job over here is if it gets too hot in here, shut it all down. That would be because this fan broke, or if it's an older style fan with a belt-driven motor, maybe the belt broke, or maybe there's something in the ductwork obstructing it. We can open this up and show you guys the heat exchanger. I took all the screws out except for this last one. Now we have view of the actual heat exchanger on here. So once again, from the burner, the air coming into the cabinet, going through the burner, being lit off with the gas, air, gas, spark, all that together, is gonna be going through this burner, or through this heat exchanger, and back around, and out here. And then there's multiple tubes on here, right? 1, 2, 3, 4, 5 tubes in this case of air, of combustion air and heat and flame going through and back out.